Hello everyone, welcome to my channel Chemistry by ANR. This is a topic which classes 9 and 10 students find difficult at times to write. And many a times we have seen that children write incorrect symbol, incorrect chemical formula. So let us see how to write chemical formulas. Like I have told you that this method is known as crisscross method for writing chemical formula. It is crisscross method. For this crisscross method, what all rules we are going to follow? First thing is write the symbols of ions or elements. That means you have to write the correct symbols of the elements or the entities or the ions. Write their valencies also. So let me see the first example, simplest of all, sodium chloride. So number one, write the symbol of ions and elements. The symbol of sodium is Na. Chloride comes from chlorine, so it is Cl. Now let me tell you here, symbol of sodium ion, because this again you need to follow that sodium chloride has sodium as the positive part, chloride as the negative part. So sodium, the positive ion, is Na along with the charge plus. Chloride, Cl, along with the charge minus. So first write the symbols, next write the valencies. Now number 3, crisscross the valency. Crisscross the valency. Now here you will say, ma'am, what is the valency? Where you have written this. So when I am writing plus, that means plus 1. Say sodium, the valency is plus 1, and chloride, the valency is minus 1, because I am writing the charge. So the value we will take, value of the valency, not including the charge, only the magnitude. Okay, we are writing sodium plus. So plus, when we have written, it actually means plus 1. And we are writing chloride ion, so we are writing minus 1. But when we say what is the valency, for that, leaving the sign, we will see here 1 and here 1. That is what is seen, sodium 1 and chloride 1. So crisscross means in the subscript it needs to come. That means subscript of Na, there will be the valency of Cl, that is 1, and subscript of Cl, there will be the valency of sodium, that is 1. This is equivalent to NaCl. So this is the formula. That's why this is NaCl. Okay, the formula of sodium chloride. Next, simplify if needed. Simplifying if needed means, what do we mean by simplify? We have to reduce to the lowest fraction, lowest ratio. Okay, ratio of the ions. Now, use brackets for polyatomic ions. Polyatomic ions means ions that are formed of more than one atom. So let us see again. Magnesium chloride, second one. So what was it? Write the symbol of magnesium, symbol of chloride. Okay, so then again let me tell you, symbol of magnesium is Mg2 plus, and symbol of chloride ion is Cl minus. Symbol of magnesium ion is Mg2 plus along with its valency. So this is the valency of magnesium. What is the valency? 2 is the valency of magnesium. Chloride has 1. So the formula will be obtained by crisscrossing the valencies along with the values only, not the sign. So Mg had valency 2 and Cl had valency 1. So Mg has 1. Nothing written means 1. Now Cl will get the value 2. Don't give bracket for Cl because this is not polyatomic ion. It is monoatomic ion, Cl minus. Now, next one, aluminium oxide. Symbol of aluminium is Al. Symbol of oxide is see over here. Let me show you. Symbol of aluminium Al with the charge for iron will be 3 plus. Why? Valency of aluminium is 3. And for chloride, it will be Cl minus, and for oxide it will be O2 minus because the valency is 2. So oxygen, when this is oxygen, okay, O is oxygen element. The moment I say oxide, that means along with the charge and valency, it always exists as a negative ion. So O2 minus is oxide. Now if I do crisscross of valency, that means Al will get the valency of oxide ion, so Al2, and O will get the value of the valency of aluminium, so 3. Al2O3 is the formula. So that's why here you are getting Al2O3 as the formula. Next, calcium hydroxide. Calcium has valency 2, hydroxide ion minus 1. So here again let me form it. Calcium hydroxide. Calcium has Ca2 plus and hydroxide is a polyatomic ion, OH minus. This is OH minus. Now over here you are seeing oxygen is there, hydrogen is there, so it is polyatomic. Now when you do crisscross of valency, what will happen? Ca in its, so it gets what? It gets 1. Okay, Ca gets 1 and OH will get 2. So we will not write Ca1OH2, we will write CaOH whole twice. Right? Next, CaOH whole twice we are going to write. See, the bracket is important here. Okay? Now, but let me tell you, suppose I am not writing valency more than 1, like sodium hydroxide. Okay, if I write sodium hydroxide, so here again what will happen? Sodium, the symbol is Na, valency is 1, and it is hydroxide is OH minus 1. Okay, so this is written as what? This is written as Na plus and OH minus. Crisscross of valency means both are 1 plus 1 minus 1. So here we will write NaOH. You don't need to give bracket for OH here because it is having the value only 1. If it is more than 1, then you will write the bracket as you have written here in CaOH whole twice. Next, aluminium sulfate. Aluminium sulfate. Okay, it's ammonium sulfate. So as I told you both, I have just now told aluminium sulfate. I'll show you both, aluminium sulfate also and the one which is written here, ammonium sulfate. So let us work out for ammonium sulfate, the one which is written here. So ammonium sulfate. So let me see the symbols along with the valencies separately. Ammonium. Ammonium means NH4 plus. Plus means always plus 1. So this is the symbol along with the charge, ammonium. Sulfate means SO4 charge is 2 minus. Now in the charge, whatever is the magnitude, that is your valency. So valency is coming out to be 1. And here sulfate, valency is coming out to be 2. Okay. So now if I do crisscross, that means what will happen? Crisscross of valency, NH4 will be getting, don't confuse with this digit 4, because symbol of ammonium is NH4. Symbol of sulfate is SO4 with the charge 2 minus. Ammonium NH4 with the charge plus 1. So NH4 is in the symbol. Now the crisscross of the valency, ammonium will get this 2. So when it is polyatomic, N is their element nitrogen, H is their element hydrogen, and it is getting 2, which is more than 1. You will use the bracket and write NH4 whole twice. Now sulfate will get 1. So SO4. Since this is 1, I am not giving the bracket. So NH4 whole twice SO4. Let us see here. NH4 whole twice SO4. And yes, I told you aluminium sulfate. Fine. Let us see aluminium sulfate also. So aluminium sulfate. Okay. So aluminium sulfate will have, for aluminium, the symbol along with the charge Al3 plus. You will say, ma'am, how do we know? This you have to know with practice only. Sulfate. Sulfate is SO4. 2 minus is the charge. So I told you whatever is the value in the charge is the valency. Valency of aluminium 3. Valency of sulfate 2. Crisscross of valency you will do. Aluminium will get 2, sulfate will get 3. So Al, this is not polyatomic, so it will get Al2. Sulfate, polyatomic, and it's getting 3, which is more than 1. So SO4 whole thrice. These are the subscripts. These are the subscripts. So this is the value. These two are the subscripts. So this is the formula, Al2SO4 whole thrice, aluminium sulfate. Now if I say aluminium nitrate, okay, so suppose I say aluminium nitrate, you need to pause the video, write the names, and just find out the formula the way I am showing you. So aluminium has symbol Al, charge 3 plus. Nitrate. Nitrate is NO3 charge minus, means minus 1. Do crisscross of valency. That means Al will get 1, so we are not writing. Nitrate is polyatomic, having nitrogen, having oxygen, and this is 3, which is greater than 1. So use bracket NO3 and whole thrice. This is aluminium nitrate. Okay, next we are going to see here. So the important rules are what? Metal written first. Everywhere we have seen metals to be written first. Okay. Now charges must balance to 0. See, whatever is the charge over the positive part, metal part, and the negative part, the counter ion, ultimately you are seeing there is no charge. Okay. Initially I am writing NH4, I am writing plus 1, sulfate I am writing minus 2. In the formula over here there is no charge remaining. Okay, so use bracket. Brackets are to be used for polyatomic ions when they are more than 1. reduce to lowest ratio. Reduce to lowest ratio. Now, the common mistakes are what? When like I'm writing calcium hydroxide. Now, this is an incorrect method. Why? Because OH is polyatomic and it is getting 2 means more than 1. So, you have to use this bracket. OH whole twice. Okay. So, if you write Ca or OH2, that means hydrogen is 2, oxygen is 1. But the moment you are writing CaOH whole twice, OH is whole twice here. That means oxygen is also 2, hydrogen is also 2. Not reducing the ratios. Suppose the ratio of the metal is to the counter ion is 2:4. So you have to reduce it to 1:2. Okay. So next, right, like say forgetting valency of radicals, that is also one mistake. You write incorrect valency, so incorrect formula, incorrect symbols of the entities, and so incorrect formula. Now, like sodium chloride, I find students writing NaCl also. So this is wrong. Why? Sodium will always have a capital N and small a. Chloride will have capital C and small l. So this is the correct thing. Okay. So next, quick memory tips I have given. That is, group 1 elements will have valency 1. Group 1 according to the periodic table. Group 2 according to the periodic table will have the valency same as the group number, valency 2. So these are the examples being given, and these are the common things which you are told to remember. Here also there are tricks from the periodic table, but as a beginner you have to remember the valency, like Al3 aluminium oxide 2. So H plus, NH4 plus means 1, SO4 2 minus means 2. Now like say carbonate. Okay, carbonate is a counter ion. Carbonate means CO3 2 minus. So what is the valency? Valency is 2 because this is 2. So CO3 2 minus, carbonate. Suppose I say sodium carbonate. Okay. So let me show you sodium carbonate. Sodium carbonate. Now when I'm writing sodium carbonate, symbol of the positive part sodium, Na plus ion. Carbonate, CO3 2 minus. So here the valency of sodium 1, valency of carbonate 2. Do crisscross of it. Sodium will get 2. So write Na2, CO3. Now you may think this is polyatomic, that is having carbon and oxygen. Then why aren't we giving the bracket? Keep in mind that it may be polyatomic, but over here it is 1. It should be more than 1, then you will give bracket. Okay, suppose CO3 whole twice, then you will give bracket. Let me show you another example. Okay, say calcium carbonate. Suppose calcium carbonate. So as many examples I am giving, all you need to jot down in your copy. Calcium carbonate. So for calcium, Ca along with the charge 2 plus, carbonate CO3 2 minus. So valency of calcium 2, valency of carbonate 2. Now here you have a chance of reducing it to common, I will say simplest ratio. So if you write it, Ca gets the valency of carbonate 2, CO3 gets the valency of calcium 2, but you need to reduce this to the simplest ratio between calcium and carbonate. So this we will not write. This is incorrect. So what we will do? Simplest ratio CaCO3. Why? Because the ratio over here of calcium and carbonate ion of the valency was 2:2, which we are simplifying it is 1:1. So we are writing CaCO3. Okay, so now let me see over here some other example, practice question for you. But for this I need to give you the hints. Like potassium oxide, I told you potassium is K plus. Potassium oxide, potassium is K plus and oxide is O2 minus. Okay, so valency of potassium is 1, oxide is 2. So I think you can frame the formula. Calcium nitrate, calcium is Ca2 plus, nitrate is NO3 minus. So valency of calcium 2, of nitrate 1. So I think you can write the formula. Aluminium sulfate, I have shown you this. Ammonium carbonate, over here also I think I have told you. Ammonium is what? NH4 plus. Carbonate is what? CO3. 2 minus is carbonate. So ammonium has a valency 1. Carbonate has a valency 2. So you can find out the formula. Magnesium phosphate. Magnesium Mg2 plus. Phosphate PO4 3 minus. So Mg having valency 2, phosphate having valency 3. So I think you can do the crisscross and find out the formula. I would appreciate if you write the names of these compounds which I gave you in the comment section and write the formula over there, such that I can check whether you have done it correct or not. So remember that these things can be mastered only with practice. Then you will be familiar with many such radicals. So bye all of you. I will give you more and more practice session with the topic chemical formula.